Now check for bell-shaped distribution with these graphs and they all look good. Now let's look at some summary statistics. So we'll run data analysis here. Okay, go to data analysis, and we'll do descriptive statistics for the utility charges. Okay, the first row is label, and let's put the output over there. Okay, and let's request summary statistics, and that generates the summary statistics for us. Now we want to see whether mean, median, mode. So that is mean, median, and mode. So mode is a little bit lower, but they seem to be pretty much in the ballpark. So mean, median, mode are very close. Mode is slightly smaller. Okay. Now let's look at empirical rule. So number of standard deviations. So we'll go from -2 to -1, 0, 1, 2, and 3. Okay, and we'll do the upper limit. Okay, for standard deviation. So mu is the mean, absolute reference that, plus z sigma. Sigma is standard deviation, absolute reference that. So that gives us an interval. So that's the upper limit for -2 sigma. Okay. Now we can run a frequency distribution. Yeah. Remember frequency distribution, which is the array function. So first highlight and then do frequency, the data range. Don't include the label. Data range, comma, bin range. Bin range is the limits that we just got, and then Control Shift Enter. Okay. Now let's do a cumulative of that. Cumulative is the first one is the same. The second one is the previous cumulative plus the current frequency. Okay. So that gives us the cumulative frequency, and the cumulative percentage would be you take each cumulative frequency divide by the total number. Absolute reference that total, and you get the cumulative percentage. So these are the pieces of information that we need to be able to verify our empirical rule. So plus or minus 1 standard deviation. So here plus or minus 1 standard deviation is between 84 and 18%. So it will be like that minus that gives us the plus or minus 1 standard deviation range, which is supposed to be like about 68%, and we have 66%. Plus or minus 2 standard deviation would be that minus that. We are supposed to have 95%, and here we have 96%, which is really good. So empirical rule checks out, mean, median, mode being the same checks out. So every indication is that normal probability distribution assumption for the utility charges data is a good one. Okay, one last thing we will do, which is the normal probability plot. Okay, which we have to do in StatCrunch. We are still in StatCrunch. Okay, so go to in StatCrunch, the graph that we want is QQ plot. If you do a QQ plot, that QQ plot gives you the probability plot. So now right click, copy image, and let's do right click again and paste special the bitmap. Now once again we see that it is going up and down a little bit, but it's pretty close. It's very good actually. The points are very close to a straight line. So considering all this, we can conclude that normal probability assumption for the utility charges is a very solid one.